upload the video in the YouTube, no? So here you can see this yellow diagram, no students, yellow node or yellow circle. See here I have a yellow circle. I have a yellow circle. See, is for this yellow circle anything is coming in and anything is going out, students? Yes? Can anybody tell me? For this yellow circle, if anything is coming in and anything is going out, ಬರ್ತಾ ಇದೆಯಾ ಏನಾದ್ರು? No, because this is a single node. For to this node, nothing is coming in and nothing is going out. So here we can call as a the in degree is 0 and the out degree is 0. Correct? No? In degree is 0 and the out degree is 0. See, the same thing is given here in the definition. A DD path is a sequence of nodes. Yes, it is a sequence of nodes in a graph such that in case 1 it consists of a single node. See, now it is single node, so the in degree is 0 and the out degree is 0. Why? Because nothing is coming in and nothing is going out. And now I'll connect this. Yes, now the in degree is 1 and out degree is also 1. Correct? No, students? Because in degree is 1 and out degree is also 1. Why? Because some input data is coming and some output data is going as an output to the next node. So that in degree and out degree values will change. So this is DD path. The same thing I have shown in the diagram. Test coverage matrix. In the test coverage matrix, so here we have a Miller test coverage matrix. Here we have a predefined values for each Miller test coverage. If C naught, then every statement, C1, every DD path. See, this is here we have a predefined values. So with the help of these predefined values, we can use in our program. So there are we have some of the types in matrix-based testing. That is statement testing, DD path testing, depends pairs of DD paths, predicate outcome testing, multiple condition coverage, and loop coverage. These are all the types of matrix-based testing. Yes, students, this is very important. This is very important. This is a equivalence class testing. So what is, 1 second, students, I'll take one empty slide and I'll explain you once again. So equivalence means what? First you tell me what is the meaning of equivalence. So, a student, tell me what is equivalence? What is equivalence? Yes, students, can anybody tell me what is equivalence? Students, can you hear me?
Equivalence means partitioning the test cases or like yeah, ma'am, like partitioning.
Partitioning the test cases. Hmm?
Yeah, ma'am.
And
Condition to be equal.
yes, see, the general meaning of equivalence is the general meaning of equivalence. Just I'm asking the general meaning of equivalence is equal to something. If my assumption, if as I told in the previous class also, if I want to purchase a Dell laptop with 20 with pro- uh, i5 i5 processor, but that laptop is not available in that shop. Then what he suggests to us, what he suggests us to, in Dell company we don't have i5 configuration laptop, but in HP I have, in HP I have, or in Acer I have. So equivalent to that, if any other varieties are available, then they are going to show us. So here in equivalence class testing, what they do, the main data will be divided. It will be partitioned. The data will be partitioned. The data will be disjoint. The data will be divided into two categories. Not exactly two categories. The data will be divided into subsets, so that to save the time. I told the rice example to students. So in a shop, if I have a 20 varieties of rice, out of 20, maybe 10 are basmati rice, and 5 are sona masuri rice, and other 5 varieties are some other quality rice. So if I want to purchase basmati rice, then I will not bother about the remaining 10 varieties. Why? Because he has already segregated out of 20 varieties, 10 varieties of different 10 different varieties of basmati rice, and 5 are Sona Masuri rice, and 5 are some other quality rice. Correct? No? There, what is happening? There, the time is saving because he has done the partition. He has done the partition, so the time is saved. Similarly, in equivalence class test also, we do the partition, and based on the partition we apply the test cases. So the use of equivalence classes as a basis for the functional testing, it has two motivations. What are those two motivations? Is we would we would like to have a sense of complete testing, and at the same time we would hope to avoid redundancy. So what happens here is we are avoiding redundancy. Why? Because here every time we are not going to check the same rice. See, are you understanding the rice example, students? Yes, are you understanding the rice example?
Yes, ma'am.
Okay. So after this example, one more example I'll give if you want any other example also. So here what is happening in equivalence class, the data will be divided, or the data will be partitioned, so that we can do the complete testing and the time will be reduced. The redundancy will be avoided. The redundancy will be avoided. So here my other person will come to the shop and he wants to purchase Sona Masuri rice. So what he do is, in the shop 20, when the 20 varieties of rice is available, then he is not going to see all the 20 varieties. He will check only the 5 varieties. Yes, there what he is doing, he is doing complete testing. Yes, we are achieving this now. We are achieving this complete testing, and there he is not doing a redundancy. Again and again, he is not checking the same rice. Why? Because he has done the proper segregation. The shopkeeper has done the proper segregation. He has segregated the Sona Masuri rice separately. He has kept Sona Masuri rice separately. So if they mix, what happens? Every time we may go to same variety of rice, and we will be in a confusion which one to buy. But here, he has done the proper segregation, proper partition he has done, so that we can reduce the time, and we'll reduce the redundancy, and the complete testing can be done. So he can check all the five Sona Masuri rice, and he will purchase any one or any two rice. Um, the equivalence classes importance of equivalence is they form a partition of a set. Partition of a set refers to collection of mutually disjoint subset, the union of which is the entire set. So here partition means a mutually disjoint subset. So whatever the collection set is there, so 20 varieties are there. So for out of 20 varieties, so we are doing a subset, that is basmati rice, Sona Masuri rice, and the other ordinary quality of rice. So, so we are doing the proper subsections. So this equivalence class testing is divided into four types. That is weak normal equivalence class testing, strong normal equivalence class testing, weak robust equivalence class testing, and strong robust equivalence class testing. So weak normal equivalence class testing. Can anybody tell what is the weak normal equivalence class testing? Anybody? See, in weak normal equivalence class testing, what happens? What happens? The here the word weak means single fault assumption. Here the word weak means single fault assumption. Yes, you can see here this is a boundary. It is a boundary. Within this boundary only we have to do the checking. In this boundary we are checking a single fault. We are checking a single fault, and within the valid range. Within the valid range. Whereas in strong normal equivalence class testing, we are checking the fault multiple times. We are checking the fault multiple times. See, compared to the previous example, in here only single value will be. See students. See students. See here. The, assume that this is 0. 1 second. 0, 1, 2, 3. So here only one value is tested, here only one value is tested, and here only one value is tested. Whereas in strong normal equivalence, more than one values are tested in each phase. In each phase, more than one value is tested. So here multiple fault assumption we are doing. In the previous case, only single fault assumption we are doing. In strong normal equivalence, we are doing a multiple fault assumption. And weak robust class testing. What is the meaning of robust? Yes.
Well,
Strong.
strong.
Any other which is related to this equivalence class testing? Yes. Here Robust means the we are checking the values which is out of range, or we are checking the value for invalid values. See, see here, when you see the previous examples, the values are within these dotted lines only. The check here, the blue circles you can see students. So these are all within the boundaries. But in the case of robust, the values are out of range also. Understand? Yeah, this one where I am pointing the mouse pointer. See this circle. This is out of boundary value. This is also a out of boundary value. Correct? Ah? So robust means we are checking for the invalid. We are considering invalid values also. Robust means we are considering invalid values also. Rob the the robust part comes from consideration of invalid values. Consideration of invalid values. And here in robust we have some assumption, that is for valid input we use a valid class, and for invalid inputs we say as it is a robust value. Robust means the values which are out of range. The values which are out of range. Yes, you can see here now two circles I have shown. You can see, you can compare the previous diagrams. The values are within the range only. Here no value is with no, the checked value. The checked value or the values are all within the range only. But in the case of robust, the values are out of range. In the strong robust equivalence class testing, here strong means multiple value checking. Robust means here the values which are out of range. Yes, you can see no the values which are out of range. Equivalence class test case for the next day problem. What are the conditions of next day problem, students? In next day problem, mainly we have three conditions, that is month, day and year. The month should be 1 to 12. The month value should be 1 to 12, and the day value is 1 to 31, and year you can limit the range. Here you can limit the range. Here the year which they have taken as 1812 to 2012, you can change it to 1900, or you can extend it to 2020. But the values which we are going to test, those values, that year value should be within this range only, within this range only. And here we have some of the invalid values, that is month is less than 1. Is it month? Do we have any months which is less than 1? The month is starting from January, that is 1. So this is invalid value. And month is greater than 12. We have only 12 months. If you take a greater than 12 value, then it will become a invalid value. And the day is less than 1, invalid. And the day is greater than 31, invalid. And year value, I have taken 1812 to 2012. If you take less than that 1812, then that will become invalid. If you take greater than 2012, and that is also will become a invalid. So these values are, these M1, M2, M1, D1, Y1 are valid values. M2, M3, D2, D3, Y2, Y3 are invalid values. Invalid values. And this is some of the example here. The day value and month value we have taken. The day, the month value may be either 30 or 31, or if the month is February, again the value of month will change. Why? Because in the month of February sometimes the days will be 28, and some, in the special case the days of February month will be 29. The equivalence class testing for the commission problem. Commission problem. Can anybody tell me what is the problem statement of commission problem? Yes, can anybody tell me what is the problem statement of commission problem? Respond, students. If you don't respond, then what is the use of revision class? Gudia, can you tell me the problem statement of commission problem? Gudia,
Yes, ma'am.
can you tell me the problem statement of commission problem? What we are going to do in the commission problem? Arjun,
Yes, ma'am. Ma'am, we'll solve the commission problem using previously you thought, no, ma'am, equivalence class testing. We'll analyze through that
hmm,
and we'll derive different test cases
hmm.
and then means we'll send the result, ma'am.
Anu, Anu,
Ma'am,
how you solve commission problem?
commission problem.
Ah, yes.
Ma'am, we'll set a range.
What range?
If we say if a salesperson sale is certain range, then this much percentage of commission they'll give, ma'am.
So how you are setting the range?
Per month, if they sell more than the range, then they'll give this much percent of commission like that. We'll set, ma'am.
Hmm. Your answer is not clear. Can you elaborate? How you can solve commission problem? Or how will you solve the commission problem? Okay, students, here in the commission problem, we are going to do the partitioning of the values. See here, the values of log L1 is for log, and the value is the value of L. Here, main thing is this problem is depending on the sales. Here, one owner is there, that owner or the manufacturer is going to manufacture logs, stocks and barrel, and he has hired some of the salesperson and he has told them to sell the he has told them to sell the price sell these products, and he is giving commission on each sale. and every day he has to they those salesperson has to report him how many products they have sold. So here some of the conditions are there. That is the value of L1 is equal to logs 1 to 70, and the means this the minimum range, the minimum value of log is 1 and the maximum range is 70, and if the log value is minus 1, that is then that is an invalid value. Why? Because the sales starts from the value of sales start from 1. So that's why if you take log's value minus 1, then the loop will repeat, and the stock value, the range of stock value is 1 to 80 and the barrels is 1 to 90. 1 to 90. And here we have some of the invalid variables. These are all the valid variables and these are the invalid variables. That is, log's value is, if log is 0 or log is minus 1, then that's invalid. If log is greater than 70, then it is invalid. Why? Because the value, the logs is only 70. The manufacturer is he's manufacturing per day only 70 logs. If you take count greater than 70, then it will be invalid. If the if the stock value is minus one, less than 1 means 0 or minus 1, then it will be invalid value. If it is greater than 80, it is invalid. Less barrel value less than 1 is invalid and greater than 1 is invalid. Sorry, greater than 90 is invalid. So these are all the invalid conditions. Equivalence class test for the triangle problem. In the triangle problem, we have four conditions. What are those four conditions? Is you there are chances maybe the given triangle may be equilateral or isosceles or scaling, or it is a not a triangle. If all the values are equal, if all the values are equal, then the given triangle is equilateral. If any of the side is not equal, if any of the one side is not equal, then it is isosceles. If none of the sides are equal, then it is scaling. Or the last condition is it is not a triangle. Based on these conditions, we do the equivalence testing. Traditional view of traditional view of testing levels. Yes, students, this I'll do it in the next class. This I'll do it in the next class, students. Answer your written students. Astha, Abhinav,
Present.
Aishwarya,
Present, ma'am.
Amrish, Amrish, Anu,
Present, ma'am.
Arbaz, Arjun,
Present, ma'am.
Ashok,
Present, ma'am.
Benita, Bhargavi, Bhavisha,
Present, ma'am.
Chaitra,
Present, ma'am.
Dev,
Present, ma'am.
Diksha,
Present, ma'am.
Deepika L.
Present, ma'am.
Deepika M. Murli.
Present, ma'am.
Gangubai.
Present, ma'am.
Gudia.
Present, ma'am.
Harshit.
Present, ma'am.
Ginger. Kavya. Kavya. Kishore.
Present.
Lata.
Yes, ma'am.
Manisha. Manjunath.
Yes, ma'am.
Nayana. Nilanjan.
Yes.
Nishant.
Present, ma'am.
Pavitra.
Present, ma'am.
Maithili.
Present, ma'am.
Priyanka.
Present, ma'am.
Pavan.
Present, ma'am.
Akash.
Present, ma'am.
Rajeshwari.
Present, ma'am.
Rakesh.
Present, ma'am.
Ramya. Rashmi.
Yes, ma'am.
Ravi Shankar.
Yes, ma'am.
Rizwan.
Present, ma'am.
Vishal.
Present, ma'am.
Savita.
Yes, ma'am.
Shruti.
Present, ma'am.
Sneha.
Yes, ma'am.
Spurti. Srinidhi. Srinidhi. Srinivas.
Present, ma'am.
Sunil.
Present, ma'am.
Vaishnavi.
Present, ma'am.
Vinny.
Excuse me, ma'am.
Kavya ಹೇಳಮ್ಮ.
I'm Kavya present, ma'am.
ನಾನು 2 ಸಲ ಕರೆದೆ. Vinny is there, no? Vinny. Vinny.
Ma'am, Ginger.
Ginger. ಯಾಕೆ ಅವಾಗ ಆನ್ಸರ್ ಮಾಡಲಿಲ್ಲ?
Ma'am, network issue.
ಸರಿ. Deepika M. Bhargavi. Benita. Amrish. Abhinav. Ramya. Srinidhi. Okay, students, I'll stop here. Okay, students, thank you for attending the class. See you in the next class.